you for letting me come here today. I hope you had a great afternoon and a rock star morning. This is a Juniper Cove theme park or theme ride renovation. I'm with Salt & Sea Technologies, Tar Roads. I am the chief nerd here to present our response to your proposal. So really quickly, this is the agenda. A few things that we'll go through. And by the way, if you have any questions at any time, I'm happy to take a break and answer those questions. So who is Salt & Sea Technologies? We are a systems engineering and architecture services company. We have 17 years in the defense industry. And why does that matter to you for an amusement park? Is because we bring to the table a lot of years of environmental qualification testing. So we understand what it takes to get a system designed and built and through the qualification testing out to production. We also bring in that experience of operations and maintenance. Salt & Sea itself is a small company, but we have strategic partners, and we have strategic partners with NOLAS and NOLAS Mission for Defense, which is specifically down in Southern California. So we have a deep bench that we can reach back to for any experience that we need. The problem overview. As we work through the problem statement we received in a proposal from Nexus Entertainment, the roller coaster Old Glory is closed. We understand that it had went through a lot of rigorous monitoring and maintenance, but some structural compromises, specifically the vibration, compromised that wooden structure, ultimately creating some safety hazards. And we understand that you closed that for the safety of the patrons. We understand that is one of the biggest concerns of the park. And that is our goal, is to bring something forward, and we focus some of our work on that. So this proposal on the next couple of slides is going to step through a recommendation to help you modernize the experience for your visitors, and then bring in that current kind of environment that most people experience today. Plus, we want to just bring that into the experience of the park as well. So not just Juniper Cove itself, but expanding by bringing in this whole new structure. As we work through that proposal you provided, we pulled in all the requirements. This is just a simple example of your key needs and goals. Broke them down into the requirements, and within our system model, we were able to pull in I think we have like 75 requirements now. I believe as we work through the detailed architecture, once you approve our proposal, then we'll work through a detailed presentation to give a more refined requirements base, where we can trace these requirements back to the design, other decisions, the whole aspect of the project itself. So if I do my job well today, you'll see I'll touch on some of these key items as we go through this presentation. We started the top level part where we broke this down into use cases. We took the basic scope of work and broke it into those top level use cases. A lot of what I'm presenting today, I'll tell you, is focused more on the project itself, because we deem that the project, this is a comprehensive architecture, not just a physical blueprint of a roller coaster or an amusement park. So we took that scope of work, we pulled it into the 4 use cases, and beneath each one of those use cases and subset activities that we would work through. And as we build this architecture, we'll refine that through. What you see on the left-hand side is Salt & Sea Technologies and the people that we would bring to bear in the project. And this is just a small set of people that we see at the top level. As we refine the architecture and get more into rolling the sleeves up and getting to the work, we'll expand that list of team members. And then what you see there is that all of those 4 use cases we have to include, because we understand that every plan that we create, we want to engage Nexus Entertainment, bring them back in and approve the plans. We want agreement in the way that we're bringing this forward. So we know that every plan gets that review, and then if necessary below that there are other plans that will be worked through. So the market analysis, we received a detailed spreadsheet that provided us a bunch of data, and we dug through that. We spent some time to try and understand the market, at least some of the survey that have been conducted in order to understand where to go forward. So we looked at the 2 aspects, well there's 3 here. So the left side you see is the ride categories based on the information that was provided in the analysis. We're focusing in on that red block where we see basically the those kind of interactive, moving, motion type of rides. That's where the greatest interest is. And then if you look at the intensity, there weren't many that really wanted the heart attack ride there at the 10. They basically sat in the medium to the moderate level of intensity, ride intensity. We didn't see gender as being a bigger issue here because we saw pretty much an even break between male and female. So we didn't think that the kind of ride we would propose would be affected by that type of gender breakout. So we really looked more at the kind of ride, what the park had, what we see the market survey gave us, and then the type of intensity expected on that ride. So that's how we focused our proposal. So what is this proposal? We're coming forward, we think there is a great opportunity to bring a new type of ride in, and we're going to call it Juniper Cove Tower. It's going to play on what Disneyland had, the Tower of Terror, where you go into an environment, it would satisfy several aspects of the proposal that you have and within a market survey where having that structure would put you inside environment and give you that dark environment. We think that that's a real win for the park simply because you're not exposed to the weather out here, right? And in Ohio, there's the opportunity of hot and steamy summers, northeaster blizzard-like winters. So now we've got a climate controlled environment, and we'll not have weather stop any of the ride. We'll also have that ride itself with the embedded sensors. So you'll have throughout the experience within that structure, within the Juniper Cove Tower, you'll be able to sense basically almost 5 senses, right? If we can get movement, sound, the senses, and then some of the 3D more those kind of senses, because the last item that we're proposing is that terror experience with an end of ride drop, whether that's going to be like the elevator in the Tower of Terror, or it could be a roller coaster of some sort. The other part of this proposal, I want to point out, it's not here in the slides, but I would like to point out is that as we did the market analysis, we looked at the number of patrons that came through the park. We believe that by we can have the wait lines not exceeding what we currently have with the roller coaster or anywhere in the park, because what we can do is incrementally cue the patrons through the ride, through the experience. So they're not standing in line for one, like a roller coaster. You have one roller coaster, everybody has to wait for it to make the cycle. Well, in this case, we can incrementally let patrons into the park and then work their way through the park. So it's going to be a much quicker turnover on the patrons, but it's not a shorter experience for the riders. So the other aspect of this proposal is that we have 2 options based on what you had presented to us, is that we could go with the opportunity to buy new land and build a brand new infrastructure, but that meant there was a significant cost of bringing in all the elements required, plumbing, electricity, all the amenities that you need to support the infrastructure. Or we could build on the existing footprint, right? So we knew that there was going to be a demolition cost of the existing roller coaster. There's no way about it. You have to remove that roller coaster. So we think that there could be a partnership between Salt and Sea, where we'll come in and take that $40 million budget and we'll build this infrastructure. Nexus Entertainment still has to deconstruct or demolish the existing roller coaster. So if the entertainment company will take that cost, then we can absorb all of that budget back into building up this new infrastructure. And I think that that is going to be a win-win for both sides of us. We'll clear that spot and then we'll bring in a whole new infrastructure. The other part too, I would say, being in the Navy, my experience is that space is a commodity. And when we live on land, we take advantage of it because we just go in the southwest sprawl, I'll call it. I've learned that what you do is you look up and look around. And by bringing in this facility, we can build up your current structure right now. Your roller coaster is one structure in one shape, right? within this structure, what we think we could do is we're gonna go up higher. That's gonna take advantage of the viewpoints. It's also, you could have an opportunity to put like a rooftop restaurant up there, so maybe some entertainment up there. We also are evaluating the idea of removable or moving interior structures such that, you know, your floors are always gonna remain the same. Structurally, you have to maintain that floor. But if we can build the walls so that we can shift, occasionally we can change the layout of that. Because how many times do you go to Disneyland and you can ride a ride so many times and you already know you're gonna go around this corner and up that, right? So people are gonna go through, but the ride is gonna change every time. Any questions? So digging into the nerd side of it, let's get into the functional architecture. So what we did is, and this, what I'm showing you today, really shows more the focus on the project itself. Those 4 key areas, budget, plan, schedule, focus then on the theme plan, and then the staffing plan. That's what we say are key activities, and then you see the lower level activities. Budget is a key item. I will tell you that we, in our rush to get this out to meet your submission deadline, we had an oversight on our budget slides, but happy to come back at our time and expense to present all of our budget information. But needless to say, we are not forgetting the fact that there is a need to understand the various costs of it. We did see that there was a need to do either a recurring cost or a one-time cost. We think in this case, we could do an analysis on the two and then give you a breakdown. In the project plan, we're definitely into plans. We want to make sure it, the old saying says that if failing to plan is planning to fail. So we want to make sure we have those plans, and within those plans, I'll show you later that we also are looking at risk. Schedule, obviously the important part. We understand that we're in an area that experiences different kind of weather events, so we'll take that into account when we build our schedule. The theme plan solution, that's the most important part. We understand that. So we're going to take a market analysis, extend that market analysis to a greater depth to understand, make sure that once we build that Juniper Cove Tower, we understand what the patrons might see. We also know that in the state of Ohio, there are, I believe, 14 amusement parks. So some are in the proximity of Cleveland, or Juniper Cove, forgive me. But we also know that there are some around the larger state of Ohio. What we want to do is understand what brings people from the further areas and what of the local proximity leads folks here. So we want to dig into that market analysis and more understand that. And then the staffing plan, probably one of the most critical parts. I believe that Juniper Cove, being very invested into the community, has kept the staff. They've probably reallocated them to other features in the park. We want to see if we can bring those folks back. And then the more important part is maintenance and operation, right? Dig into the logistics. From our defense industry aspect, we understand what that means, and we can bring to bear a lot of knowledge in the logistics, sparing, supply chains, and other aspects. So we dig in deeper a little bit, and we look at a different perspective of it. What's the park? And so we look at the park itself, and then we see 3 basic areas or groups of the park. We have attractions, the park operations, and then the patron service. Those things in green, we've got a legend here to help you just visually see where we're at. We've got a lot of activity, active rides, and services. But what we're proposing is that red block at the bottom where we're going to remove Old Glory roller coaster, and the yellow block is what we're going to focus on. That's where our proposal is at. Apologies for oversight on this one, but I had mentioned on the immersive experience, and we're also discussing amongst our team, could we bring in a virtual or an online kind of experience that would bring it into the Juniper Cove Tower as well, because we want to get the non-in-park people to engage, or the opportunity to continue to engage. Could we gamify that Juniper Cove Tower? So we would extend on that. As we work through building out this architecture, this is where we're seeing, where we're tracing what we have in our structure, or physical structure, what we see, and this is just a small subset of that. And then we have the large, behaviors, the activities that we will implement within this architecture. So you see a lot of the focus is across the Juniper Cove Tower. That's where we're focusing on, but I think there's going to be more as we start refining this architecture. And I mentioned earlier, risks and opportunities. Right now I'm just presenting to you a single risk. We think this is, and you see it's number one, we think this is probably the most important one. Certification schedule. Our experience in the past is that if certification doesn't occur, nothing else can, right? It doesn't matter how sound the physical product is. If you can't get certified and authorized to operate, that's the problem. In this case, we think that if the certification plans are not accepted by the governing agencies, then the project schedule may be impacted. And so we see this affects the schedule, the cost, and the performance. It's every aspect of the project itself. We have a comprehensive risk plan where we will work through defining that risk. The bottom left, you see just the simple mitigation plan and this mitigation steps that we would go through. And then you see down the bottom right, the risk cube, where we think we start in every step as we work through. In this case, for the certification schedule, we want to make sure that we meet with the all stakeholders on the certifications. We understand in the statement of work and the proposal, there was a large list of regulatory compliance requirements and laws, federal, state, and local. So we want to understand those, make sure they're captured in our certification plans, work with those agencies to address their concerns up front, and then we're ready. We should have a signed and approved plan 60 days before required. Because the other part too is that executing a certification test, you know, you have to have the plan, but you have to execute the test. So is it something that's going to be outside, or does it require coordinating some other resources? We need to make sure. So that's our goal. So as I said, this is just one example of a risk. We have a full risk register that we can provide. And with that, I want to pause. Again, I want to thank you for your time and listening to our proposal. Hopefully I addressed your concerns. If I have not, I have the model ready. I can show you if you're interested in any aspect of it. Otherwise, I'm open to taking your questions.
Thank you very much. So we just
just play the role of you know, if you want to dig in deeper, if you want to see the model, whatever you think you need to score against the rubric.
Yeah, I think seeing the model would be helpful for our organization.
I didn't bring my readers, so bear with me. So what can I do to help you? So let me walk you through.
Okay.
Instead of making you guys try and pick one, let me walk you through. So this is our landing page, right? What we do is we go in and create a landing page. This is what we do in every architecture. We create the landing page, gives you a navigation through the thing. We pulled out information from the proposal so that we could build out our proposed architecture. So again, you've seen this picture. You see what we're trying to present here. What I can do is walk you through. We understand what the original footprint is. This is how we came to the conclusion that it was better to take the existing footprint, and that's why I said we can fit in that footprint, because what we're going to do is build up. Then from that footprint, this is the other part. We took a look, did a quick search on a website, and I have links in here to some of the reference sites that we use, but you can see on this map, we have a cluster around Cleveland. Juniper Cove is somewhere in that area, but we see a few other parks. There is some other statistical analysis that we can take advantage of that will give us more information on amusement parks. One thing that we did see is that top parks, actually the United States in the world, the United States only has like 3, I think, out of 10. 4 were in Japan, then China. So it's interesting that we don't have a lot. So we'd like to help you get there. Let's go. I showed you this use case, and we can get in here. This is a simple breakdown of these use cases, but there is more. We need to work through on the part of those plans that we will develop is the testing, and what is the test output. We want to lean in towards automated testing and everything that we can, not only in the actual physical design, but in the architecture that we would deliver to you. Within the requirements, here's a full table of requirements. You see them grouped. So we pulled everything that we saw within the proposal, we pulled those in to create the requirements. As we build these out, we'll start refining the requirements. Right now they're basic. What I wanted to do in this proposal was to extend these and to create extended requirements, add that detail to create the risk level so that I can start doing some analysis on those requirements.
Were you able to do any like verification analysis? Identifying maybe how, in terms of like inspection analysis, demonstration or test for the requirements?
Did not get to that. We ran out of time during the challenging, and we wanted to get a proposal in. Hopefully that we can come back with more detail to you.
Okay.
So I showed you, let's see, I showed you the functional architecture. And then the actual theme park. And then, as I was working through this, as the team and I were working through this, we were trying to work through, I chose to stay at a block level because I'm still not at a point where I want to dig into the actual guts of the system. Wanted to bring into what we saw as the actual tower run systems and the things that we would put in that, and then the physical buildings. So I see those as two separate. Even though they're physically going to be in one space and they're somewhat connected, you're not going to separate the building from the ride or the ride from the building. But I still see those as somewhat of, the building is an external, but then the ride itself, right? Because I want to kind of create a, what I would call somewhat of a logical separation of those two, because I want to maintain the building infrastructure within the entire park system, and the ride itself is going to have its own maintenance system. And the colors. So as I was refining, as we were refining through this proposal, it was a matter of, and I think this was in the proposal as well, is that it was upgradability. This is the life cycle of this. We know that you want 25 years for this ride, and that's why I was saying the movable walls will be one thing to look at. If we can bring in more of the current AR, VR, some interactive, maybe robotics, we'll be able to start bringing that in. So in this first analysis, we know that we can do the in-carriage sensory components. What we want to do is long-term create that game, create the virtual environment. Could we create an environment where somebody can have their smartphone on them and have the engagement within their smartphone, and then an interactive system? Could you take that ride and then bring that outside of the tower and bring that online? So I think there are more opportunities as we expand this. And I think if we also follow a modular approach, componentize, decouple instead of hard coupling on things, then we'll be able, that'll create more flexibility in the final solution. And I believe, yeah. So we try to bring a common structure within the model. There are some pieces that we deliberately took out. I didn't want to provide any kind of unused items here. But as we refine this, I know that we'll dig into more detail. We'll have more information as far as more detail within the architecture and more of the SysML-like requirements. We'd also like to bring forward, we have done this on other projects where we have connected system model to CAD model. We'll connect it to an acquisition, we'll be able to produce bill of materials and other items. So we think that we can extend the architecture, bring you to a true digital engineering environment. Is there anything else I could show you that I haven't?
No, No, I think that looks good for the model.
Are there any other questions?
Yeah, so you showed the layout of the current right, and then basically you're taking the entire spot there, right? And as I understand, there are some food trucks surrounding the old one. So
Yeah, sir, so to your point, that would be another advantage to staying our current footprint. We're not gonna impact any other aspects around the park. Everything, we believe that because things are already built around something being there, we think there's a lot of things that we could take advantage of. So, sticking within that footprint, because if I understand the explanation is that the food trucks, I believe, are up in this area. I believe this was the area for the new land. It was proposed to be a parking lot. Leave that space to be used for something else, and then let's use the existing space. Because again, I believe we can build up and put more into that tiny space.
if I understood correctly, there are some food trucks around this attraction in the gray area as well, right? So in your case, in your solution, you can just incorporate them into the building, right? The first floor of the building.
Or we could do that.
Yeah, you mentioned in the beginning that you looked at you didn't really look or see no difference in demography, specifically in gender. Any considerations to the age?
We did look at age. Didn't have the numbers in here. We did look at an age, and there's a wide range in the survey. The average age that we saw was 39, give or take years. So you're looking at like, so we want to target between 30 and 50 for a specific reason. Not necessarily because the market survey said that that's where the average was. That was just that market survey. But we think that that is the age group that is going to be most active going to the parks, right? 50 is the new 30, 60 is the new 40. So I think that we can get in that age group. They're going to have a range of family, non-family, and then you're also going to have more well-established within life, career, and financial budget, so they can support that, right? So that's what we think we can target that 30 to 50 range. I think that would be a prime spot. And then if we do well enough, right, we get the parents in there and the kids are young, then the kids love it enough, they come back more with their kids.
And in terms of sustainment, I think the solution here is that you can change all these attractions because some of them are virtual, right? And in this case, you can
That is
keep
correct.
up with whatever, and then you can plug in, say, Captain Walrus in there and stuff
Oh.
like that, right?
Right? We could sit Captain Walrus right there next to you in the car. That's a good point, sir. One of the things about pulling this inside a structure, like I said, it's environmentally controlled, right? So you're not going to have the whole exposure of the wind. It's not salt water, but water still is horrible on structures. So we have a greater opportunity of extending the life of that structure.
Two minutes.
2 minutes.
If you guys, you don't have to use all 2 minutes, but we have 2 minutes left in the thing, so.
Shannon, back to you.
I think I'm okay.
All right.
Me too.
Thank you
very
so
Thank you
much
very
for
much.
being first and coming up here, you did a great
Again,
job.
thank you very much for the time. Rock it out.
Awesome.
you. Thanks everyone for the opportunity to present on the problem that was put to us. I did introduce myself yesterday to your judges. Dan Spencer, I'm all the way from Australia. My company name for the purpose of this process is Tanti. It's a local Ghana language from where I'm from the LA Plains. Means shining or standing out. So I was trying to get something to link back to where I'm from and what we're doing, and hopefully there'll be something shining or standing out about what I've provided for you. So I'm going to go through. I've included in the pack here. I've got in the submission. I had a range of spreadsheets with some detailed data on there that's come through from the systems architecting. There's two presentations in there, one which was the Blue Sky presentation that we went through yesterday morning, and then the final one. I have included the overview some of the overview from the Blue Sky presentation here as well, just to give a flavour of what it is that we're looking at. I know you guys have had to look at quite a few of these just to remind you about what we were talking about in the Juniper Cove replacement. So there was a lot of there are quite a few layers of requirements that were delivered to us in the pack for this. This is the very high level statement of work that we're looking at. I brought that. I do find it useful to bring that into the modelling tool that I use just to get my head around things and to use this tooling to make sure I'm covering off everything. My big focus for what I've actually done here is about traceability, so making sure that every decision that's been made is traceable in there back to the source information, and there's some sort of analysis done to bring that back to the problem that we're trying to do. So making sure we have things. So the Blue Sky process was around answering some questions about what is the location, the ride type, the theme, and some innovation ideas onto that. The bits of analysis that I did on that was based on the market data and some some quantitative analysis on the market data, and then some qualitative things around what we knew about the location or the existing park location at the time. So there are a few things there. We made a decision at the time. I'm not going to revisit too much about that at the moment. My approach was to try not to replicate what's already in the park, to get some new and diverse things with the limited information we had there about what actually was in the park, and drawing some conclusions from looking at the imagery that was provided to us as well. So yeah, the end result of what we came up with to present here was to look at a dark ride attraction and trying to bring in some other ideas around motion simulators and roller coasters. There were a lot of responses there dealing with the more movement-based in the market data. There was a lot of responses around the movement-based things. So try and bring some of those concepts into the dark rides, and we'll talk to a specific component of the solution that we've chosen in the next part of analysis on that as well. The theme that I came up with at the time was a historical link back to Eleanor's park vision and the location that's there, so being linked back to the lake area and the pines, those sort of things that Juniper Pines is named after. Looking for a full immersion experience. I had highlighted a couple of things around gamification, some sort of scare thing, to see if that would happen, and bring in the art to the entertainment side of things as well. So, right, that was my pitch from yesterday. So getting back to what we're doing, as I mentioned, my big focus has been on trying to get a proper analysis from this point into something that's actually going to be feasible and useful. So this is taking the systems engineering concepts and tools and approaches that we have, and identifying a couple of areas that we can do. The big effort of what I've tried to do is to get full scope of everything that we have, so that it sets things up for a realistic project success into the future, rather than spending a lot of time on marketing materials and that. I'm a systems engineer. I do understand that business needs to be sold on a lot of things, but highlight on my particular focus areas of doing the analysis to solve things that we're looking at. So, process that I took, worked through the blue sky session, won't talk too much about that. Requirements identification analysis, as I said, there were quite a few requirements in there, which is good. So I brought those into my model, did some review on those to classify them, to get some structure around those requirements in my model environment, and also to derive the requirements that we had, which were design decision requirements made in the blue sky session, and what I'll also and further analysis of the marketing data as well. From there, worked into kind of iterated between the physical context and the behaviour identification, kind of in parallel. So physical context, looking at the I fixed this up. First thing was a high-level architecture definition, just what the context is, those high-level physical interactions, into behaviour, so simple-ish identification of behaviour at this stage. There's only so much could be done across the board of what we're doing. Then we get to an actual physical architecture design, so looking at some main solution systems to meet that blue sky analysis. Apologies for the typo, these didn't happen. I identify required physical architecture from the constraint requirements that are there as well, and having those that physical architecture trace back to those constraints too. So design and traceability. Then I got to analysis. So I wanted to make sure there was something meaty and useful about this approach in there as well. Why are we doing this model-based systems engineering exercise to support it? I've done a bit of analysis through some simple systems level simulation to come up, because there are a lot of constraints around and performance requirements that were detailed for us, and I wanted to make sure we could build the main system that we're doing there. How do we actually scope the sizing for that? So there's some analysis done there, and I'll show you the results of that. I might try to bring up the live version if we've got time and show how that can be tweaked as well. So from that analysis, the decisions made, then we get some output design requirements out there. They're all derived, they're all traced back to the analysis that's been done. And I spent a bit of time now on verification and validation design, and part of that was around not just coming up with that original requirement set, but looking at how would we verify and validate. This is only the starting point for a real design for the system that we're going for there. What I made sure I captured here are the key things as that design moves further. How we're going to validate that meets those requirements, and then how we're going to verify those things once we have a built system as well. The earlier we get that from experience, the better we're going to have results in our project. I've seen a lot of issues with that on real projects, and having that traceability, having that coverage of that verification validation to cover the full scope of requirements is what I was going for here as well. Still, preliminary, but I know that if you took this model now and developed and designed things further, that you would get a good solution out of for the project that's there. Safety and risk analysis. What I've done on that part is to highlight some of the key areas of architecture that were built to meet the safety requirements, and then that links back to the verification side of things too, which pulls out one task that hasn't been completed, but a clear task there of looking into the production of a proper safety plan. I've spent a lot of time on those in my work life that can be useful. Let's have a look at what we have here. So, requirements, different ways of looking at these requirements. We saw these same requirements in the blue sky session in a system of requirements diagram. This is just the table view of the exact same information that's in there. We're really looking where we've got to at this stage is really in that early stage of the design and engineering. None of the detailed design of what the part designers would actually do has been involved there. and you know the definition of that safety and compliance side of things is my focus. So we used a lot of the marketing data in there as well. Originating requirement specification. So this is the and apologies, that's why I put it in a separate spreadsheet as well. I don't expect you to be reading this, but this is the pull-in of the. I'm actually going to bring that up because there are a couple of. No, actually, I'll zoom in on this rather than doing that because there's a couple of things I will highlight on here. This is the specification that was provided to us about the model. So you can see what I've done here is identified the type of requirement which determines how they will be dealt with throughout the other modelling there. So everything's got a type, has a structure there as well. It's a hierarchical structure, and I've broken things down where there were sort of combined requirement statements there. I've broken them down to individual statements. It was pretty good actually, that requirement set, to be honest, and we don't normally see good requirement sets. So there was stuff there. We have the parent requirement. We have traceability back to the actual paragraph number that it came from, and actually in the tool, if I bring that up later, we can actually hyperlink directly back into that source requirement document as well and see that. The notes are stored in separate area in the model as well, which will help any future designers being able to actually look through that and see what the these notes are not really specification text. There are other things in there. So that's all model. This isn't a spreadsheet that I produced in Excel. This is a spreadsheet I've extracted from the model as well as all of the spreadsheets that you'll see. Oops, too far in this presentation. All right. So that's really just a first level analysis on those requirements and bringing those in. To behaviour, this is a fairly simple high level flow of behaviour from a customer's perspective here as well. So I have activity diagram here. We have a bunch of things happening in parallel. This will simulate as well. This will actually execute if we run through it. Not to show anything particularly useful at the moment, but just to validate that it does meet, it does do some actual behaviour as well. So we have a customer arriving, queuing. We've got a queuing part of the system, a subsystem for queuing to handle that queuing. I've got a subsystem doing attendee recording and camera purposes. This is for to be able to sell those photographs and videos back to the customers as well. I have some control systems, which is around controlling the vehicle and path. That's related to some of the derived requirements that we'll see later on as well. And then I have my main vehicle within the attraction, which is a non-tracked autonomous dark ride vehicle. And I'll talk more about that selection shortly. But there's a few reasons why I selected something along those paths that would actually work with the overly constrained amusement park ride that I've chosen for myself. I realised after looking at this that with the passenger numbers and everything that we're dealing with, it's pretty tight on what can be done. So we have a flow here, everything happening in each of these running in parallel. Customers arrive, they queue, they board, they traverse around the path of the attraction. We deboard them. The customer can view that photography purchase if they choose. They can leave, and the autonomous vehicle resets for the next trip. So this is just a single iteration through that, and a fairly simple one, not covering all of the aspects of the physical architecture at this stage. But so we have that. This is a system activity diagram view of that. We have the same thing in an enhanced functional flow diagram. Just can be useful to kind of have different people working in these different diagram types here as well. So this is the exact same flow. It's the exact same thing we're seeing there, just rotated 90 degrees. Bit of a different view on the same things. So any questions on that at this stage? Happy to take any questions as you go along. Make sure that those functions that were included on that last page are traceable back to the requirements. So these were just looking at the behavioural requirements, so the functional performance requirements that we had, showing some traceability there. I did make one change just before I came in here to the presentation material, which was just to put a white background on this thing, because in the fluid version it was quite hard to see, especially the green lines. But that's that's the only change I've made here. Just want to let you know. So we have traceability back to those requirements. That's a matrix view. We can see. I could show the same thing in some box and line diagrams as well, but I think that's a useful one to see that traceability. Getting to the physical architecture, this is the very high level context. At this stage, I've just identified a couple of external systems that interact with my dark ride system. The customers, obviously, is a key one. I want to see how that experience is happening for them. And I've got a maintenance and security side of things as well that kind of got drawn out by looking at some of the other aspects of the physical architecture and what they need. So this is a top level physical block diagram, just showing those interactions between things. You'll see there are a few links there. They dig down into the detail of that next layer of decomposition of the physical architecture that we'll see shortly. So, selection of the, how are we going for time, Dave? We've got 10, 15 left?
13.
13, thank you. So, basis of the design, as I said, the actual system that we're looking at, the whole attraction had a lot of constraints around, well, a lot of expectations of how many people we would be working through the attraction, their queue times that they would be happy with. And what I did find is, looking at the detail of the market data for the dark ride attraction, there was a lot of expectation of a long ride time for those. So we're talking average of over 25 minutes. That's a long time when you start, and that probably makes sense for that particular ride type that we're dealing with there. But in the given that I had in the Blue Sky session constrained it to the smaller location, which is the footprint of the existing roller coaster, that kind of constrains things quite a lot. So this is an actual real world example of a dark ride concept here, and this one is a trackless. So most dark ride vehicles are tracked, but there are some autonomous vehicles that are out there on the market at the moment as well. I didn't get the name of this one, sorry, I should have probably included it in there, because this is the actual marketing material that's included. But this is a trackless autonomous dark ride vehicle. It does give that bit more flexibility when we're dealing with an environment that you could actually determine the I guess virtual track of where it's going to go, and then have a little bit more better ways to deal with the constrained area that we have there. Bunch of details about what it includes. It has 4, 6, 8 or 12 passenger variants. My next part of the simulation analysis allows us to use those as parameters going in there. It has a lot of abilities to do 6-degree of freedom movement and everything. So that adds in that part that I was looking at of trying to get a lot of some movement and that customer experience of what they're expecting there. And interestingly, it came up with some options, particularly on VR, AR, and augmented reality and gamification. So these were other things that were mentioned in the pack that would be useful to possibly add into that dark ride vehicle, so to have that more than just the one experience in there. So getting down, I'm going to zoom in on this one again, into the actual physical architecture design. This was working through some of those constraint requirements and what was actually required, and a little bit of other design aspect of there as well. So we have in the middle here the non-tracked autonomous dark ride vehicle. There's a lot of links between, this is not a physical block diagram of things, so we see the two externals highlighted there of the customers and maintenance, and security. So we have a security camera system, we have safety alarm and alerts. So I'm highlighting a couple of things that are important to things that we'll talk about later on. Safety egress and evacuation paths, working through some of the Other research material that I did yesterday morning, that's a key aspect of design that needs to be dealt with early. That all relates to the arena structure that we have. We'll be putting up a structure around that to make it a dark ride. It needs to be indoors, essentially. Queuing area that was drawn out in that behaviour side of things. There is location here for theming the immersive visuals that will be part of that as well. Now, at this stage, that's all I've done. Didn't have enough time to know I'm not a theme park designer, I'm a systems engineer, so I'm going to leave the further analysis of that themed area, how that's going to meet the vision that we talked about to further areas of design. But so that's our physical architecture. Disembarkation area was drawn out in the behaviour as well, and that's all traceable to that. Actually, I just will switch back to one. Not too far. One thing I just will note in the behaviour diagrams, you can see that each of those functions on the EFFBD actually has the traceability through to the physical architecture component there as well. So that's something I didn't need to draw out before. So getting to the fun part of analysis, what the quantitative part of what we tried to get to here, and to do something useful here. So in order to size that system solution, so I'm looking to use those autonomous vehicles. How many of those vehicles do I need to make this work? Well, we had a lot of parameters in there to start with. So I've used my requirement numbers in there. They can be traced back to the actual originating document, but we have accommodating no less than 50 guests every 10 minutes. The park is open. Ride time of 26 minutes. That was a derived requirement that I came up with based on the market data. Queuing time of no more than 55 minutes. Same source of information. Thank you. And what I've decided, because this was looking tight as I ran through the first initial simulations, I've gone with the 12 rider car. When we see the simulation, you'll see there's no alternative. So this is a very simple simulation model we have. What this is showing is customers arriving in a queue. This is a resource of customers in a queue being produced each time a new customer arrives. They're arriving at a random time. What I did in the initial run was having them arrive one by one. As that turned out, if I was to do another iteration of this simulation now, I changed that to be, batch grouping of these things together, because it became a little bit too uniform when it was individual people. So we'll see that, but that's very simple to change and update later. Still got the result that I wanted. We have a replicate construct here of the number of vehicles that we're looking at. So what I did is run tests with different options, how many vehicles there would be there, and the intent of this was to look at, with the given ride time, so traversing the ride path, adding in some extra details for resetting, for loading passages, unloading passages, taking in 12 passengers at a time on this branch here, looking at, okay, how many does, the first instance of this simulation was to check, is that queuing stable or does it indefinitely grow, I should say. And as it turns out, example here, sorry for the very small again, but this example here at the bottom is with 11 cars, and you can see this is the queue. You can see kind of little dips every 12 that go. It's growing and it's never getting down. So 11 was too few. If I move over here, and this is where it became a bit too uniform. It is randomised, but it just wasn't. It's a little bit too uniform. It's that queue then becomes stable at 12 cars. So that answers my question. I need 12 cars to make this happen with that design decision that's in there. So just to highlight what I have there is the customer queue there, and then we've got each replicate instance of those functions of customers boarding, traversing the ride path. Most of that time is spent traversing the ride path with that. I think it was a 26-minute ride time that we decided on there. So that's and then the magenta areas is just when the those vehicles are waiting for passengers. So we want to minimise that as well. Obviously, you can ignore that first half hour where it's just starting up the simulation. Oh, now I can roll it. Okay. So derived requirements. We have ride intensity. These were things came up in the blue sky. The vehicle type and number is the main thing that we got out of that analysis there. That's been derived. We can see it's a design decision. We have rationale for all those design decisions that were made, whether they be blue sky, simulation analysis, other analysis of the market data that's in there as well. So that's all traceable through. Then we get to verification and validation. As I said, I spent some time on doing this, but it was still fairly simple. We have 7 main areas of verification and validation that are defined, and that covers the full scope of what's in the requirements. So both the originating and the derived requirements that we have gone there. Different methods that are appropriate for each of them. As it turns out, because it is early stage in the design, a lot of these were analysis, which is not best practice. We want to do everything by direct test if we can. At this stage, when we're looking at things like marketability, running surveys to people further surveys as we actually progress the design is important. We've got safety in there. Yeah, it should cover off all those requirements, the verification that we have. And again, another one that's further, this kind of looks from the other perspective. This is all of the requirements. This is the verification cross-reference matrix. So we have detail of the requirements in there, the type of requirement, what it's verified by, and then the detail of the verification requirement in there as well. So that covers off pretty well that area. I've got a couple of minutes, so we'll just zoom out without zooming too far. Sorry. Yeah, 3. Thank you. Safety related, just very quick thing on there. We have 3 components that are identified to be safety related at this stage. So the safety ingress and evacuation paths, security camera system, and alarms and alerts as well. We have tracing to the 2 main requirements on that. So the safety standards and the compliance area, and then the verification activity there, verification requirement at this stage, which is around the development of a full system safety plan, adhering to the requirements that we have there, is how we actually plan to meet all those. Obviously, I haven't done a huge analysis of that from the safety side at this stage, but it's my key focus was to have those pointers there that things would be done. So aim to get broad coverage of everything, so nothing is forgotten about later on. Always more that can be done. That's where, if there is any scope for questions at the moment. Yeah.
Probably good time for questions.
Yeah, thank you.
Any questions?
Sorry, it was a massive information dump. So
No, you did a good job. You didn't do it all, sure.
Could you just go through again real quick the traceability for the functional, physical architecture to your requirements of functions?
Requirements of functions, yeah. I might just bring up the tool quickly. Sorry, I should have had this open, but it'll take a minute to get in there. So yeah, all of the, well, I believe, I'm not 100% sure in the time that if I've got 100% coverage on all the components should be, well, I'd say the majority of the components that are in that design are traceable to the constraint requirements.
Okay.
And from the behaviour too. So the level of behaviour that I've done at the moment, every function is being performed by a single component in that physical architecture. Where's my agenda code? There. So yeah, I can view that in a few different ways. Probably have a matrix that's.
So you have traceability from requirements to function, and then you have allocated each of your functions to a single component.
Absolutely.
Okay.
Yeah. So that's the functional allocation matrix here. But that one's probably more easily viewable in those functional requirements to, yeah, that's this one here. So if I have I have the requirements down here and the functions across the top.
Okay.
Some of those included, just with the way I've set it up at the moment, are high level functions that are reset for next trip. There are some functions that are just necessary for them, not actually derived from the requirements exactly.
Okay.
It's very impressive model that you created, and you also show the scheduling. So I wonder, so if you can show us, the traceability of the schedule that you created to one of the requirements, and what happens if you're changing the requirement. So, for instance, it shows two-seater right now, right? What if you change it to four-seater?
Yep. I know I'm out of time to show it, but I can change. I'll show you the boarding vehicle, so I can see we are boarding 12 at a time. It's just a matter of changing that parameter there. If I wanted to reduce that down, I need to run that simulation again, and this one will start growing indefinitely. I'm not going to run through the whole thing, but you'll see. No, I can't. I need to run through the whole thing for it to. Otherwise, it's going to be. It's very because I'm doing individual things. It's very slow to process bit by bit. We see, that's where we see problems.
So it's a effect. Sure. Okay.
So excellent. Thank you. So I'm sorry I didn't leave enough time for questions.
Okay. Thank you very much.
Thank you.
I appreciate that. I do not want to take more time than I should.
rescue. And basically what I've kind of done for this proposal is I've set up a requirements table in Cameo, which goes through basically all of the requirements that were put in the initial proposal, and then I tried to tailor them to the ride, Goldie's Juniper Rescue. So, a little bit about some of the requirements and just stuff from the initial phase that I'll reiterate here. It is a themed ride, so I have that under this requirement. So basically, Goldie is a gold crest bird which lives in juniper trees, and it's going to guide guests through an adventure to catch this evil deforestation corpse that is legally cutting down juniper trees to fuel its factory operations and bring them to justice, so to speak. I did want to highlight that part of the attraction theme with the new movie that's going to be coming out, Captain Wars will be making an appearance since they kind of have aligning missions, with basically trying to save the planet and such. So during the ride, he'll have a cameo to provide assistance to Goldie and the patrons as they try to catch the deforestation corporation. The attraction is a dark flat 4D in motion simulator type of ride that was decided upon based off of the market analysis. So a roller coaster was the top choice. At 13 customers that were surveyed chose that, but the others spread out around 11 people per each of these different ride types chose these. So I decided to go with this primarily to do a kind of dual intensity model to the ride. If you guys have ever heard of or ridden like Mission to Mars in Disney World, they basically allow guests to choose their intensity. So if you want to do like more intense version or less intense version, basically like the amount of motion and jostling that occurs during the ride. Because the average intensity that patrons were choosing, like if you averaged them all together, was at about a 5. I think it's best if we cater to everybody, and allowing them to choose that dual intensity kind of provides that, so you guys can get a lot more guests in versus like if you chose something like a roller coaster, which I feel like cannot be made to varying intensities. So trying to cater to everybody there with that. All of the other requirements are quite standard with whatever the spec said, so attraction, capacity no less than 50 guests, every 10 minutes the park is open. I did set the ride duration to be 10 minutes, so the average in the market analysis was about 13 minutes of ride time. Just from like personal experience, most rides are not very long in amusement parks, so I thought 10 minutes, kind of scaling that back down is the right choice, and it also allows to rotate guests more quickly throughout the ride. I also inputted a max queuing time of about 30 minutes. That was, I would say, not the average time that people would like to wait, but in order to get the breadth, I would say over 98% of the people surveyed were willing to wait 30 minutes or more in the line to go to a ride. I think there was like about 3 or 4 participants out of the whole lot that were only willing to wait 20 to 25 minutes. I did want to indicate the power and water infrastructure needs. So since I am building on the existing location of the Old Glory roller coaster, I did limit the infrastructure to this level of power and water to be used on the ride as well, because that's what the existing infrastructure with that roller coaster kind of stands. And I did want to mention that the purchasing of the 2 new anchors I would recommend, just because I believe at one point in the initial spec it said that there's potential for more profit, down the line. So I think by building this new attraction at the existing attractions site will provide cost savings in the existing infrastructure that can be utilized, as well as whenever the 2 new acres are purchased, half of which could have been used for this new attraction, utilizing that for possibly even another attraction down the line, and the other half for parking. This method of using the old allows. So, I did put the full project timeline to end on July 10th, which goes in line with the whole movie release part as well. And then I will scroll down here to some of the operational requirements. Again, in line with basically everything put in the spec. I just generalized the ride, as well as all of the safety requirements being tailored to the ride as well. Any questions right now, or do you guys prefer to hold questions to
At
the
the
end?
end.
Okay. Cool. So the next thing I'm gonna kind of go into in the model is the functions. So I made a functional diagram for just a generic provide new attraction experience. So if I scroll this way, I tried to do a generic activity diagram to illustrate all the different functions that Goldie's Juniper Rescue would have to perform to kind of get patrons in and out of the ride. So the inputs and outputs are basically the patrons throughout, but basically the patrons are going to be indicated the height and weight limitations of the ride, as well as health and safety warnings per the initial requirements that were given. Then the patrons are gonna have to queue up in line. And then because we are a 4D experience ride, which would include a 3D element in the visuals, we're going to communicate to the patrons to take 3D glasses and also provide 3D glasses to them. And then from there, we're gonna guide the patrons to their ride seating and communicate safety instructions to them following that. Then the room's lights will dim, and I have a forking of kind of the different experiences during the ride. So we're gonna have a 3D media on the screen, kind of narrative going on at the same time as narrative audio playing through speakers. And then providing differing immersive like water effects at the same time. So for example, as you're exploring Juniper Cove and trying to take down the deforestation corporation, pass through any like water features through the cove will, initiate like water misting and stuff like that on the guests. And then we have the motion platform mechanics, since we are partially a motion simulator ride. So that'll kind of provide the jostling, and then also incorporating the flat ride mechanics. So, the lifting from the ground, curling motions, as they try and catch the deforestation corporation. Once the ride is kind of in its end stages, the lights in the room will brighten again. We'll communicate for them to return their 3D glasses and to provide a return for them, and then patrons will exit the ride. Next, I created a lower level IBD of the ride and its different components and how they're going to interact with each other. So one part of it is the patron seating. So the type of convention I tried to follow was the port name just kind of follows what's happening, followed by the ending location. So this would flow out to the patrons. So there's a generic interface here of human contact between the patrons and the seating, which should end up following all the requirement standards human envelope, making sure there's like no jagged edges and such for safety between the patrons and the seating. And then we have a mounting structure between the seating and the seat poker, as well as the motion platform. So the seat poker is going to receive power from the existing infrastructure. Basically, it's going to get controlled by the ride controller, which is down here. And then we also have the 3D glasses, providing that human contact with the patrons, basically giving them that 3D experience, and will be subject to the same safety requirements as mentioned previously. Then we have the room lighting, which I have existing power infrastructure interface with, as well as providing lighting to the patrons so they can either see around the room, or the lights can be dimmed and provide kind of that more immersive experience with the media that's being played at the same time. This is also going to be receiving controls from the ride controller. And then as we kind of move up, we have the motion platform. So the way this kind of works is the seating is mounted to the motion platform, and the motion platform is mounted to the flat ride mechanism. So I think this is probably the best way you can incorporate all the rides at once. The motion platform gets power from the existing infrastructure, as well as provides movement to the patrons. And then we also have the flat ride mechanism, which also has very similar infrastructure in terms of getting power, providing movement, and getting controls from the ride controller. We also have the water effects system, which provides water effects to the patrons, also applicable to safety and comfort requirements in terms of temperature and exposure duration, power incoming as well from the existing infrastructure and being controlled. And then we have the speakers and the projector system. The speakers providing audio, receiving power, being controlled. The projector system providing the visuals to the patrons, as well as receiving power and controls. So that's all I have modeled, and what I was able to get to at the time. I wish I was able to provide some test cases or verify relationships between the requirements and stuff like that, as well as drawing, functional allocation relationships between the blocks and the functions that were created. But this is what I was able to do in the time allotted. Do you guys have any questions or comments?
Thank you. Shannon?
For your requirements, for ones that you derived, did you just, were you able to trace to the originating ones, or?
So,
thoughts on that?
they're all based from like the existing ones.
Okay.
There wasn't really any derivation beyond the, I guess with like the user ones, trying to chase from like that marketing data,
Okay.
if that makes sense.
Yeah.
I'm trying to understand the concept. So we have a single platform with multiple seats in it, or what is it?
Yeah, I wish I could draw this for you, which Cameo is like not the best at. So the idea is like if I have a chair, like the one I have here, this table will be the motion platform. The chair would be sitting on top. The motion platform does this, providing the motion, seat poker, water misting, whatever's attached to like the seating and such. The motion platform is attached to a flat ride mechanism. So, are you aware of how that kind of like looks like?
The right?
Like a flat ride, if that makes sense, like that type. I can pull one up and we.
Well, my question is, I guess you claim that the benefit of this approach is to have the different intensity of the rides.
Mm-hmm.
So in this case, each individual platform, moves differently.
So typically, you would have the ability to. There would be a pre-programmed setting for each of them. So you probably put the patrons that all want the less intense experience on the same like seating and motion platform and flat ride, if that makes sense. And then if the guest wanted the more intense experience, then they would be grouped together into that separate motion ride platform. So it's kind of, we have like separate groups groupings on those, like, the ride is basically the same, it's just the level of jostling that's would be different.
So in this case, so it's kind of separate seats. The reason for acquiring additional lot, what is that? To expand it further?
One more time?
Well, you are using the existing footprint, right?
Mhm.
To build it, and then you mentioned that you want to purchase some lot of parcel, right? To perhaps extend it in the future. What? Or you are purchasing and building something at the entire larger location.
So this ride that I'm describing would live on the existing footprint of the old roller coaster. I would recommend, like, just from a business perspective, since there does seem to be a perhaps expansion in revenue from using this new land, to purchase both and use half for the parking and then half to build a new attraction beyond this. So it kind of gives you guys the flexibility to use what you already have, but also now you have space for a brand new attraction, if that makes sense. Or whatever you guys need in the future, whether it's like parking or whatever, it doesn't have to be an immediate decision.
This is an internal, right, facility or external?
Internal to be like an indoor
Indoor
situation.
something. So the fact that you changed the date of delivery somewhere, will it affect anything? You think it should affect anything?
Well, I think with any smushing of any deadline, right, there's going to be increased risk there when trying to meet that deadline. I think when you have also tighter deadlines, you're probably going to get an increase in cost as you try to push people to go faster. And obviously, safety risks as well. You have to make sure you still pass your inspections, but obviously tighter deadline there as well.
Okay. Any other
I'm good.
questions? Good. Thank you.
All right.
Thank you
Yes,
so very
thank you
much.
very much. Thanks.
afternoon. My name is Gavin Barnes, and I'm here to present The Chase, Juniper Cove's next great attraction. I'm with Top Hat Incorporated, a pseudo-subsidiary of SAIC, and I'd like to lay out for you a story. But before that, let's talk a quick bit about how today's going to go. From your request for your RFP, you had laid out two end states. You wanted a phase 2, which walked through an economic, technical, and operations considerations, as well as this rubric that was in there. So the rubric content will be focused in the technical section, and then reference back for your technical discussions, and then economics and operations in their section in kind. And then we'll talk a bit about capital walrus. So first, let's talk about the story. The way the chase starts, you're in the Appalachian Trail, going on a lovely day drive, and all of a sudden a monster jumps out from behind a tree. That monster chases you along the crests and the ridges and the mountains until you fall into this lost, forgotten government lab that turns your car into a rocket ship that sends you into space. And of course, it's a monster, it will follow you, and will chase you around the earth until you will crash down back into Lake Erie. Will go drive around underneath water because it is a space rocket underneath water submarine car now. And then it will breach and land on Old Glory, the storied roller coaster of Juniper Cove, and end just as you did as a child, ending with the standard Old Glory ending. And all this is made possible with the ride that we have come up with today. Now, this ride incorporates lots of the interests that we had pulled from the available likely visitor data. It has mountains, it has underwater, it has space scenarios, it has mild scares in its vigorous ride, and has a continuous narrative weaving it all together. But how do we find our way there? So the first part, let's talk about the ride itself. This is a hybrid 4D motion simulator ride. From the available data, we had pulled 74 people. The top rides were roller coaster, 5D, which is really supposed to be 4D. I'll have to talk to my interns about that. Flat and water-based rides. So the roller coaster was 12 people, had called for that one. The other three were each of 11. However, what we realized is 4D and motion simulation rides combined got you to 24%. That 24% is the significance of that not only just being more people, but 4D motion simulator can combine recreate most of those other types of rides. So at a base, it's 24%, but had the ability to reach far more interests. And so we saw this as a fantastic opportunity to have growth and immersion, and create this ability to reach a greater audience. Now, let's dive into the economics for a bit. So we performed the trade study. First, let's talk about the target demographic for the attraction. So from the trade study, we found this is equal parts men and women are interested in this kind of thing. Ages 20 to 40, so these are young adults, might have small kids or freshly out of school, plenty of disposable income, great opportunity for a group to look at for an amusement park. And so that's where we saw this additional benefit of going for that 25%, and simulating those other rides. As far as the market differentiators, so we are looking at using the DOF Robotics Riot 360 VR. And the significance here, what this differentiates from other rides in this market area, is that this would be the first of its kind 4D motion simulator with custom high quality VR movies. You wouldn't have to spend thousands of dollars going to Disney with the family when you could just come to Juniper Cove and get a fraction of that cost for all that great value. As far as how we would capture the target market capture, with the likely visitors at 25%, we anticipate somewhere of the groups that would not necessarily be going to these kinds of places, that 25% we receive reflected in those numbers. And when it comes to the profit, loss, and break even, our budget for this is $3.1 million. That is driven by the requirement that is $100 per square foot, and we are reusing the entire space of Old Glory's old footprint. So at $100 per square foot, 31,000 square feet, that's where we get 3.1 million. The cost of the NRE cost for the Ride 360 VRs is 1.8 million. That's to cover the cost of the 7 units required for this, which we'll get to how we got there later, as well as at least one high quality movie. Leaving the remaining budget for that 1.3 for the V&V and any kind of additional margin built into each of those. The recurring cost here is $45,000 or $540K per year, so $45,000 per monthly, just had a slip of that. But those being the major cost drivers in this. As far as the break even, the lead time for delivery for these devices are about 2 months. So given the 3 to 6 months for the destruction of Old Glory, we have some margin there for that slippage in schedule for delivery. 4 months for the build out of the area as well as the parts themselves, and then we've given ourselves a generous 1.5 years for testing and training. This actually puts us at about 2 years, 1 year early for starting operations. So in the original estimate for the RFP, you want it done by 3, break even by 5. We are pulling that back 1 year in margin. So accounting for the numbers provided for the estimated guests up until 2028, I believe, if you raise the ticket price by just 60 cents per ticket for that 6.9 million visitors you expect in that 2-year window while we're operational, you would hit your break-even point in those 4 years from the start date. Okay. Moving on to the technical deep dive. We're going to focus on the rubric content and then shift into how that translates to the phase 2 questions. So first order of business, sources of the stakeholder needs and how do we identify them? You have 30 pages of glorious RFP content, super easy to read and great to parse. From that, we focus on those top level documentation. So the main one was the memorandum that had the formal scope of work, but as well as from everything else, we were able to parse additional needs, things like testing and validation requirements. So from that, we distilled our way down to these use case profiles, or these use cases. Kind of standard operations, system maintenance, the EES, which stands for the Entertainment Experience System, as well as system tests. And so from that, you can see how we identified major actors are the maintenance workers, the ride operators, and the guests, as well as the experience design studio, who are the people making our movies. From a hardware and environmental perspective, there's the EES itself, which is the generic term we're using for the Chase Our Ride. This is in a problem space, sort of solution agnostic, and the environment of that ride. Where that works our way back to the requirements is here. So on the left column, you can see the list of use cases that we have just discussed, the actors associated with it, and the operations. But what I want to draw your attention to is the rightmost column, which are the customer requirements we've used to capture each of the core items listed in your memorandum. So this is coming back to those top level requirements. And I should note, there were hundreds of requirements in the actual documentation, most of which are actually captured in our model, but these are represented as some of the most top level set of the originator. And you can see how they trace from the use case to those requirements. Now, as far as the use cases, regarding the functions of the resulting system and how they relate to the actual model itself, I will take you to this one. So here we have, so these use cases, we've begun decomposing them. In this case, on the left, you see the entertaining the guests while they're in line. So we start with a scenario with that black dot. The environment interacts with the guests while the guests are in line, ultimately exiting the line, which is what leads into the entertained by the ride itself. And we've done these everywhere you see that green dot on the right for the behaviors of the system are how those traces of the corresponding use cases. Now, I should note the green dots, these operations on the right of the table, that is all tracked and contained in the logical architecture. So we've done that initial logical architecture in the solution space or the problem space. Again, solution agnostic at that point, but showing all the expected behaviors we have for the system. Let's see, moving on to the next one. Functions. As far as how these functions trace back to the requirements, so coming back to this slide, you see here not only the use cases and the functions, but we see the corresponding requirements that are associated with those operations and behaviors. So we know that anything you see in that used operations column translates to supporting the requirements in that far right column, the customer requirements. I want to take a quick divergence, focusing back on phase 1 of the presentation in terms of the quality of the thought process for the Blue Sky phase of the project. I'm going to kind of mention earlier in the economics section, but I really want to come back to this histogram analysis. This was a bit of a trade study we did, looking at who was involved, what they wanted, and how do we maximize the reach on this ride. Right? This is we are tearing down an icon of Juniper Cove. We want to make sure we do good justice and maximum reach with this new one. So the combination of 4D solution and motion simulations is what drove us to that innovative way of trying to maximize our capabilities with this new system, only requiring video and software updates instead of full new attraction of what we have to do with Old Glory. Alright, so let's talk a bit about the physical architecture. So, physical architecture right is now in the solution space. Here's the actual hardware we plan to use. So on the left column are the components for the physical architecture. We are now officially calling out the Riot 360 VR as the hardware for the ride here, as well as the chase for its environment and the Juniper Code maintainer. So we're now calling out the names of the pieces involved. We're using the model-based systems engineering practice of using the satisfy-by relationship between the physical parts and the requirements. And so once again, we are tracing back to those the scope of work requirements that we were referencing earlier. So showing how we have traceability from the current physical architecture to those originating requirements. Okay. Now, more than just requirements, we need to consider are the key requirements. So after parsing through a number of these hundreds of requirements that you had in the 30 pages, about a dozen of these or so were identified as the key performance parameters, right? These are the most important requirements critical to the success of the system. And so we did a small customization, adding an exterior type to these requirement elements to identify a Boolean, that column on the far right, KPP, saying these are the KPPs and how we find them. And so that these are these core technical requirements. As far as ensuring they're being verified, we use the verify by relationship to associate the requirements with these use cases that are kind of top level, very high level representations of the verification methods. So here we have a collection of system testing as well as system analysis. Test being events that require stimulus to the actual system, and system analysis is more of a number crunching scenario. On the far right, you see a very simplified but representative version of what a system test would look like for a system test profile, where we have it be administering the test by the test engineer, who then executes the hardware with the test hardware, the system itself responds to the test, and then the user collects results. And so this is the kind of top level analysis we're doing with this proposal. Obviously becomes far more detailed upon selection moving forward. I should also note that these KPPs, as they are part of the original set of requirements, these are in that whole bucket of the original requirements. We did not have the opportunity this time to create derived requirements. So these are focusing on the originating set of that came in the original proposal package. Okay, let's shift back up to how the analysis, how we know that our solution meets the analysis, meets the requirements of the system. So love this one because it's just a giant picture of 3 rendered people in a big old ride. So we have, again, we're utilizing the DOF Robotics Ride 360 VR. This is a 12-seater solution. They had a 6 and a 9-seater as well. We chose 12 because maximum persons, but also easily deployable and a short system lead. However, the number 7 took a long time to get to for the minimum required number of systems to meet the program. So 2 requirements specifically drove this number. First, you had a requirement that needed 50 riders every 10 minutes. The second is that you had an uptime requirement of 82%, meaning at any given point, 17% of our operations are going to be down. In order to meet that in units of 12 people at a time, we required 7 systems. So that way, even at total failure of that meeting at 82%, 2 systems down, we still have 5 times 12 gets us the over 50. We also looked at square footage as being a potential limiting reagent. We had more than enough room left over. 2/3 of the volume, 2/3 of the square footage of Old Glory is consumed by these 7 systems, meaning there's a whole 10,000 some odd square feet left. And from power consumption, these things only take 12 kilowatt hours, and the requirement is 2,000 kilowatt hours as the limit. So felt pretty confident that we weren't missing any other limiting factors. Okay, next is why do we feel this is so innovative as an approach? I've said it a couple times, I just want to reinforce it. This ride can emulate many of the other rides, and so even though this is a subset of a type of ride by itself, with the right programming, with the right movie, we can create those kinds of opportunities and experiences for others without So I feel like that open capability just enables great opportunities. Okay, let's talk about risk. Down to the risk slide. The only truly high risk, we considered a number of capabilities as far as making sure we had tried true technologies, so there was low risk for production and schedule because we have a significant margin of that. The real risk I felt was the training demands. This is a new technology in a space which doesn't normally have this kind of high-tech stuff. So to us, and knowing how important it was for the original Old Glory to have safety and security and protection for the users, we want to make sure that is a technical challenge that needs to be addressed through significant training with our people. And for a year and a half, the time we've set aside for that, which is more than enough to make sure they have that, but that is still a real risk item that we want to be very sensitive to, especially given what motivated this entire operation event. Additionally, how do we ensure that our use case, our requirements, that our requirements are being, for safety, are ensured they are captured through the system. And the column on the right, the requirements for safety and compliance and testing quality assurance coming from the scope of work represent that top level need for meeting those requirements and capabilities. And you can see here on the left side, those are directly bound to the entertainment of the guests on the ride, in the line, and system testing. These are all core functions where we need to make sure we're safe and have full confidence in the system's capability. So starting at this top level, we are associating requirements with the use cases, and then as we decompose the system for future development and refinement, those will not be lost, because fortunately with the benefit of MBSE, we can track that traceability as it flows down through the system. All right. For discussions of walk through the model and organization, we're going to skip that unless you all like look at the model later. Not really time for that one. But that is it for the deep dive portion. So shifting gears a little higher level for the technical discussion. You all from phase 2 wanted to see the full requirements traceability from ownership expectation down to a lower level model. And so it's a combination of this slide, which is from top level requirements to use cases of these operations, and here where we actually have direct association showing from the low level physical architecture to the satisfying of the high level requirements. So we're using a meta-chain analysis to walk to these in some cases, but the trace ultimately walks its way through to get from your customer requirements down to the physical architecture. And we just covered how we have the safety governance being addressed by making the associations at this early stage of the proposal. Items 2, seeing the safety compliance testing and quality assurance, tracing to those top level use cases so that they're decomposed and built into the system as we go forward. We've already discussed risk and the concern we have regarding the users there, the trainers there, and then discussion of the trade space undertaken. So we've gone through it a couple of times now at this point, right? 24% of the users expressed interest in the 4D motion simulator, and so that was really driving space. As much as we would have liked to go with the maximum roller coaster which itself was 12%, the combined capability plus the opportunity to expand into simulating other types of rides just couldn't compete. All right, shifting into the operational space. So you have the request to determine the human, physical, and technological resource allocations. From a human gap, this is really where that risk comes in, right? We want to make sure they're updated on training of proper safety practices using these sophisticated electrical equipment. So we are building in our training practices to accommodate that. From a physical resource perspective, this takes up less space than the original Old Glory. We have more than enough space, so there's no risks there or concerns. And from a technical resource, we're not using any water really for this ride. And the power demands 84 kilowatt hours total for the 7 systems, plus a margin far less than the 2,000 kilowatt hours. Overall impact of the park, the saddest thing about it is it's changing the silhouette because Old Glory is a classic. But this is a new innovative way to step forward to stay up with times. As far as scalability goes, each Ride 360 room takes 1,500 square feet. Again, by the end of it, it's 2/3 of the original space. So if you want to add more units or do something different in that space, you've definitely got that. Or if you just want to have new rides, new movies, it's about $150,000 for a high quality VR movie, which has been built into the budget. We have at least one new one coming in just for this first announcement. And so with that said, you can definitely use that to market new and interesting opportunities like Captain Walrus, which we'll get to in a second. And the last piece of the operational part was any new requirements that showed up, evolving requirements. There were no new requirements, as Captain Walrus was not a requirement, but a, hey, please bonus So we didn't factor them as core requirements, but more of a desirement. So we saw that, but other than that, the original requirements of the system did not actually change from the original drop at the beginning of yesterday. I would now take this time to shift to Captain Walrus and take a breath and some water. Is that 10 minutes left?
Yeah, 9:35.
Fantastic. The core, most difficult requirement of Captain Walrus Desirement was that the pulling in of 14 months of the original completion date. We were pretty sporty making it 2 years out to completion, a year ahead of schedule. So the only way we can meet that is by pulling in our V&V schedule 6 months. If we do that, we'll have a month margin before the Captain Walrus event, but it creates a risk. However, we do have so much margin built in just for this. I would identify that as more of a medium technical risk or a medium schedule risk than it would be of anything else. So it didn't need to be on the risk register at this time, but it is truly a risk item for that. But overcoming that one Captain Walrus timeline challenge, we can absolutely meet that. What's more is we've already gotten the budget, that one video for $150,000. So if we divert that to the Captain Walrus promo, we can get that additional benefit and advantage from there. And so I do want to bring now in terms of where this really does showcase the significance and how good and strong a solution this is, coming back to these use cases. You see down here, this rotate experience profile. This use case is what is used to represent any time we change to a new ride. So say it's a seasonal thing, or we want to try a new movie, or a promo for Captain Walrus. That use case is what is used to represent when that happens. And so, as requested, the kind of things, this is not just a superficial media blitz for the chase being repurposed to for the Captain Walrus ride. From the visuals perspective, starting July 10, 2026, we'd be incorporating the signature aesthetics into the ride. From an audio perspective, we'd be using their iconic soundtrack. You know, when those horns kind of rise up, just gets you every time. For character interactions, we would have our ride operators dressed as core characters, but none that would limit mobility so that it can maintain safety needs. From a merchandising perspective, we would be updating the merchandise shops, of course, to facilitate that in the area. And the story integration is really where this shines, is the 4D motion simulator solution, because that's that movie we've already budgeted in. We would use that movie for that, and so it would be producing a high quality VR movie regarding Captain Walrus. We did sign on voice actors for it, so I'm very excited for that. And it would culminate as requested in a compelling moral victory for Captain Walrus and his friends. So we've already factored this into the budget, just repurposing what was originally planned, and it does incur a little bit of risk as far as the schedule, but we have significant margins for it. And with that said, that is the extent of my presentation regarding the Chase / Captain Walrus's debut at Juniper Cove. Any questions?
Thank you. I'm pretty sure Shannon will ask you to open your model.
Oh, fantastic, here you go. What would you like to see?
I was wondering, did you do any views of the architecture? So yeah, you have a
Yeah,
hierarchy
so
one here.
Didn't make the screenshot cut, but it was rapidly running this last half
And
hour.
did you consider any interfaces?
Yeah, so in the interfaces, so in this case I didn't get the time to model the interface requirements themselves, or the interface blocks themselves, but I got to the point of labeling them to identify what will be the flow through
Okay.
once I had that chance.
So this is external. Did you have any chance to consider any subsystems of your system?
Self-systems?
Subsystems?
No, but then again, Ride 360 VR is a self-contained
Right.
system. So I was able to, the way the RFP was laid out, the ask was for the entertainment experience system. So actually, from that perspective, I feel like this is the subsystem because it's the environment, all the people in it,
I see.
and the 360 VR is a major piece of it, but it is a self-contained piece. It's basically DOF Robotics drag and drop.
Okay.
You have a physical decomposition somewhere, right? Physical.
Yeah, that's this one. So this is the physical decomp, and
Okay, good.
logical is up here. See this one? Ooh, there you go. There we go. So so logical decomposition, problem space, left in the EES context, the guest, the experience system, depending on what it is, but it's all the major players. It's almost a direct one-for-one. I did incorporate actual formal names, bringing facility power, because that was, again, that was one of the major concerns is how do I know how many is enough? And so power was one of the big concerns of like, is this my limiting reagent or square footage? But it was those two requirements was what drove it in to make 7.
Can we go back to the slide showing the budget
Sure.
considerations? I wonder why you chose this,
60 cents.
no, not 60 cents, but what was it, $100 per square feet?
It was one of the requirements.
Right, but you chose it to show it that the total cost is much less than 40 million, right? Was it the case? Because
So-
the another requirement was $40 million. So my thinking is, why don't I put several floors and put 7 plus 7 plus 7? You still have a lot
Well,
of
this
money.
is still a small operation compared to like, I didn't want to, I mean, this is one of the core requirements in the discussions is what's your scalability. So, right, you can totally do that if you can open up the budget for it. But I was trying to get to that lowest value while adhering to the requirements. And truth be told, like from a proposal writing hat, right, I was given a bound, and it was just, there was so much space to work, and I was like, this is a good starting number, I can make this work. If I could make it 3 million, I was going to crack it open to 40, but I was able to pull it off, I feel, with what I had, with my very detail-oriented numbers.
All right. Yeah,
Good.
Very good. Thank you so
Thank
much.
you all so
for
much.
the
Thank you very much.
I have a couple people watching.
proposal. I'm Jeremy Ross from Brightside LLC. So I want to start off, give the opportunity for management or the judges to have a preference on what I refer to you as. Do you have any questions after reviewing my initial submission last night?
No, we're good, ready to
Okay.
digest.
I will jump through that. So, quick overview, a couple glossary terms. The main one that I use during the presentation is going to be the EES, the Entertainment Experience System, which is what I conceptually refer to Project Deep Blue or Old Glory's replacement as. So I'm going to start off by just giving you the high hits on my solution summary. So what it's called, it's Be Your Own Action Hero. So this is an opportunity for your patrons to be an action, to experience an action-packed attraction, and it's going to allow those patrons to live out their dreams of being a Hollywood movie star in real life. So we're going to bring in climactic cinematic scenes from the greatest action and adventure movies. We're going to recreate them in an augmented 4D VR experience, and we'll make sure the patron is the centerpiece of this. And so we're going to provide a solo experience so that patrons can experience this alone, to do heart-pounding solo heroics, or they can join in with a group of friends or even just new fellow patrons that they've met at Juniper Cove to conquer immersive challenges. And they can be from some of the biggest name movies that you hear, James Bond, Mission Impossible, Lord of the Rings, etc. And we're going to have this additional aspect. It's going to be big screen or small screen. We'll give the choice to the patron. So we'll have a vast selection of options and an option for continual update of the attraction, which I'll show you later in the architecture, which will allow patrons to live out the biggest scenes from from the latest streaming and TV cliffhangers as well. And again, the attraction is an indoor dark ride attraction experience, and it's augmented with 4D and VR experience elements, and it provides a combination of gamification, full immersion, and competitive and cooperative socialization aspects. So competitive if they choose to go as a group against another group, or cooperative if they want to join a group and work together towards a common goal. So that was the proposal summary. I just wanted to give you the highlights, and then we'll dive into the details, starting with market analysis, then we'll go through the layout and financials, timing plan, and the architecture. So I presented the challenges in our initial briefing, Blue Sky meeting yesterday, so just to hit those again quickly. What you told us is that you're seeing increased competition from different sources. There's the new post-pandemic landscape, which is challenging who is attending your theme park, and there's also an outdated existing attraction, Old Glory, which had a recent safety issue. And as I briefed you yesterday as well, I did a preliminary market analysis, first of all on that roller coaster aspect. So this is just going to walk through kind of how we got to the 4D dark ride experience. So on the roller coaster side, saw that these respondents were kind of a captive audience already at theme parks, and we want to diversify Juniper Cove to bring in new experiences. So this is why we're suggesting moving away from the roller coaster, also because you have the existing high-tech one with the views of Lake Erie. Also with the water ride, you have a number of existing attractions which covers this side as well, and so that minimizes kind of the optional solution space down to these 4 elements. And so the next part of the decision-making process was to understand the target demographic that we wanted to pursue, and we've weighted the selection choice of attraction type a little bit more heavily to the school and college demographic, because we see this demo as presenting a steady, continual revenue stream if we can hook them in and get them to continuously come back to Juniper Cove. And the ideal situation would be to hook them now when they're young and have them return with their families for a larger and continual market base. And we can see that the dark green in the bar chart in the bottom corner represents the school college, and they have a higher preference for the 4D experience and dark ride options. And a differentiator for this demographic, for that younger demographic, is that they feel like they missed out on experiences due to the COVID pandemic. Now that's based on the fact that we see an overall increase in travel in the world and all of these in-person entertainment experiences after COVID subsided. But that younger demo in general lacks the monetary resources of the older demographic, so they cannot travel as frequently or as lavishly. So another aspect and differentiator for Be Your Own Action Hero is that these Hollywood scenes, they occur all across the world, all across the universe in some cases. So this attraction also serves as a way for your patrons to see a little bit of a different part of the world as part of their experience, to get that travel aspect in as well. And what they're receiving is a world-class experience that's close to home and for a fraction of the overall price that they would have to pay for a plane ticket. I'd also shown this analysis in my initial background, but using a word cloud, we identified from the verbatims from your potential customers that they value experiences, story, and the world. And so we're planning to make Juniper Cove the destination to experience your favorite scenes from movies, again, whether they're on this planet, in this country, or anywhere in the universe.
Sorry, we can pause for you real quick. I'm gonna figure out what's going on.
Are we good?
Yeah, but hi. Alright.
So any questions thus far on the background and market analysis? Okay, so now we'll go into the details on the layout and financials of Be Your Own Action Hero, which is the name of my proposed attraction. So the summary of the layout, we're proposing this is on the wooded lot, which is adjacent to your existing park. Now, although the new attraction would fit in the space of Old Glory, the roller coaster, using the wooded lot reduces a lot of the timing risks, which we'll show in the timing plan that would come from having to deconstruct Old Glory and do site mitigation on that in order to meet your stretch Captain Walrus target, which this timing plan will meet. An additional advantage of building on the wooded lot site is that it minimizes disruption to your current park operations, which was one of your requirements, and it's documented in the model, so I'll show how we have that traceability later. And a key aspect of this is that because we're using the adjacent lot, deconstruction of Old Glory is not required to deliver this attraction. So what I would provide back to you is a recommendation to do an additional, more thorough structural analysis. You gave a preliminary report leading you to say Old Glory needs to be decommissioned, but if you contract an expert engineering firm to reevaluate, there may be a potential to maintain Old Glory as well as this new attraction, and we could incorporate that in a follow-on proposal after you have the additional detail. But one key part of that is it comes down to, you also mentioned Old Glory has a dated appearance, which isn't in line with where your park is going. So it's going to be really with your management team and park operations to say, is the datedness of Old Glory a constraint? Again, Be Your Own Action Hero can fit within and is planned for the wooded lot, and we'll show you the monetary impacts of that. And it's really just a minimal cost loss. And then lastly, on the Captain Walrus side, how we're going to interact with that. So this movie Action Hero proposal even came out before your stretch memo was reached. So we were already thinking of these, and we see Captain Walrus as an awesome initial branding opportunity where your patrons can relive some of the Captain Walrus franchise's biggest moments as a way to launch the new movie. And it can also draw in new people who are looking to do this experience of being an action hero, even if they're not familiar with Captain Walrus. So we see a good synergy between those. So looking at the cost analysis, this slide is just was an analysis done to understand whether it is a good, what the decision should be in terms of using the wooded lot. So based on your park projected attendance numbers, we're looking at about over 1,000 visitors per hour. Now if we look at using the entire 2-acre parcel for vehicle spots, it's approximately 288 spots, which is really around $17,000 a day of revenue from parking. We assume that someone's going to stay for about half the day to actually experience your theme park. Now, if we compare that to a projected 12% incremental, $12 incremental ticket revenue from this new attraction, I'll show you how I got to that in just a moment, and over 20,000 visitors per day, your daily revenue is orders of magnitude larger by using those wooded lots for an attraction and not for additional parking. You can see it's over $260,000 of revenue from this attraction. And then the last thing I want to mention, just in terms of quality of experience to your users, the capacity of your parking lot is around 288 spots. You're looking at over 300 cars per hour based on your attendance numbers. So this parking lot isn't sized even sufficiently to handle a lot of your incoming people. So there's not going to be a huge detriment to kind of the parking experience because there were so few spots relative to what your projected attendance is. So on that ticket price, again, we're projecting that Be Your Own Action Hero is going to drive $12 of incremental admission price when that entertainment experience system, Be Your Own Action Hero, comes online. And so this is based on the average price of a US movie ticket shown in the chart in the bottom right, and then a very conservative, modest 2% year over year growth to project that out. And the reason that we're using this price of a movie ticket is your tagline can be, for the price of a movie ticket, you get to be your own action hero. So for $12, we can bring in new patrons to experience kind of the theme of a movie, and based on that cost, we're looking at over $40 million of incremental revenue in the first full year of operation. This is the source content for ticket price, which is provided in your deck for future reference. And then for capital costs, we captured a requirement that it must either be less than $40 million total expenditure or less than $100. So I'll walk through quickly a cost analysis on how this is met. So the average indoor park is between 20 and 100,000 square feet. So if we use just one of those 2-acre lots, we have 43,000 square feet of entertainment space, which falls well within the range of a typical indoor park. And the cash up front for this acquisition would only be $6,000. And again, using a mid-range, so we have mid-range in size. Let's use mid-range in cost projection for the overall capital cost for this. We're looking at $20 million. Sources are in the next slide to give us that range. And so the overall cost to you to implement this would be in the $20 million range, plus the $6,000 for the lot, a very, very small amount. And we've captured a cost opportunity in here. Again, recall we're using VR as one of the enablers for our entertainment experience system. We see this as a potential of reducing up to 10% of the overall capital cost, because instead of using costly fixed assets like animatronics, set dressings, etc., we can augment those with relatively cheaper digital aspects to still deliver the entertainment experience for the user. And the architecture captures that, which we'll get into. This is the source for the range of costs for indoor parks. And then break-even projection. At the bottom is showing the requirement as you provided with a break-even by year 5 of the project. So our timing plan estimates operation start meets the July 2026 Captain Walrus timing. And if we assume a 25% ticket revenue in year 1, even though we're running for half the year, we're going to be conservative and say soft opening, we may not have full capacity. You can see that we're still easily meeting positive cash flow before the 5-year mark. So we meet the requirement. So timing plan, this is based on experience of projects with similar scope and complexity. We can see the overall timing plan for this. Captain Walrus start is shown in red, and then our estimated operational start is the green line in the 2026 timeframe. So I want to call your attention to a couple aspects. You can see the blue squares, the architecture, design, B&B, and safety certification run in parallel for a number of their aspects. And that is enabled by our model-based approach, which is what I'll spend the remainder of the presentation describing to you. Because we have this integrated and verifiable interlinked design schema, we're able to begin aspects of subsequent design phases in parallel with existing ones. So you can see architecture design is ongoing. We can begin B&B and safety certification work. Also, you'll notice that B&B is split, and that's because we've captured that some tests can be conducted at the element and subsystem level, whereas others need to be run as full system integration tests, which of course we can't conduct until the system is closer to full instantiation. We'll show in our test methods how we have these test types called out, and it fits into this time plan. And similarly, safety certification is ongoing throughout. We have that linked into our architecture description, so you can begin that while the architecture is being finalized. A couple of the construction items are shown in the black to get us to that final timing. So any questions on this? All right. So next we'll go into the model-based architecture, and we'll walk through this. And first of all, if you're not familiar with MBSE or model-based systems engineering approaches, a question is, why are we doing this? You know, what's the purpose and value to you, and why was this included as part of the analysis? And the reason is you just had a safety incident at Old Glory, and your legacy is on the line. The legacy of Eleanor Whitfield, your founder, is on the line. We understand as a theme park, the safety as well as the amusement and entertainment of your guests is the paramount importance. What you're able to get from utilizing a model-based approach is that rigorous, verifiable, traceable system definition, so that you can ensure the safety and integrity of the system that we're going to design and provide to you, so that your guests can have a great experience and you can maintain Juniper Cove's legacy. So let's go through what that looks like. So this is the overall containment structure of our model shown on the right, and I have the model available. We'll demonstrate a few things on the left. This is just showing how the decomposition structure in our tool begins at the conceptual source content and behavioral analysis level, and then it goes through in further levels of decomposition through the context functional architecture, which describes the functions that the system has to provide in a solution agnostic manner. And then we begin assigning structure to those functions in a logical and physical approach. And we finalize with verification and additional requirements that we've decomposed into lower level requirements from your top level needs, which are shown here. So these are the stakeholder needs, which are a specialized type of requirement. And I elicited 20 unique requirements from your project proposal, as well as the project walrus bulletin. This trace link shows an artifact in the model, so we can understand exactly where this requirement came from. And so we can see from this that the requirements have cover every aspect from the overall service life that you've requested, 25 years, compliance with safety standards, we have timing, operational costs, ergonomic experiences, down to space constraints, that break-even duration, and that we already talked about, as well as capacity. So how these requirements are used, we'll cover a little bit later in the model, but they are traced throughout each element of our decomposition to provide the why to why we have system elements. An additional thing that we did, so those stakeholder needs are your expressly stated requirements. Again, they were traced to our to your project brief. We elicited an additional set of safety goals, and so what these are the guiding North Stars for our system design decisions, so that we ensure as your customer that we provide the safety of the user and external individuals that are both enjoying the entertainment experience system as well as those in and around in the ODD. And this derivation column on the right of the chart shows how we've taken these top level guiding North Stars and decomposed them and linked them to specific industry and internal requirements that you provided in your brief. Like an example is the requirement for smooth surfaces, for the bodily clearance envelope, and so forth. And these six top level safety goals go around key aspects. So we have the prevention of bodily harm. We do not want your riders to get injured or anyone in the ODD. Then we have prevention of unintended interactions, which can be between the rider and the ride itself. They could also be between the ride and external persons, like what happened on Old Glory. The interaction between riders if it's unintended, and then we have bodily clearance envelopes and the need to secure riders during operation. Again, we use these safety goals along with your stakeholder requirements as the guiding principles and definition to why we are doing things and making decisions in our architecture. And let's look at how we decompose those architecture elements from that top level requirement shown on the left of this chart down through the sub requirements shown here to satisfy to the elements in the architecture that deliver on the requirement or they satisfy that requirement, and the ways in which we're going to ensure that requirement is met, is verified. So we use an example here from operational uptime. You told us that the system needs to operate 20 hours a day, 7 days a week. So we have some specific requirements that we've created to define more specifically what this needs to be. So we have a requirement for recovery time in the event that the system goes down, startup time from in order to get the system operational, and a mean time between failure requirement. System design choices that we've made, and we'll show you how the architecture in just a second, satisfy are the ways in which our system architecture meets these requirements. So an example that we're showing here is we're proposing a dual central control system for the entertainment experience system. So we have a backup and primary methodology, which helps us meet these requirements by providing redundancy and minimizing the time between failure for the overall system. And that's what you care about, because that's what your stakeholder requirements are talking about, the overall system. And then we have test methods, which are ways that they describe the activities or the overall approach that we're going to use to understand if a requirement is met. And so two that are assigned to this are a cold startup test, and we'll show how that's an integration test, and then a recovery time test, which is a stress test to understand the performance of the system and whether it meets this requirement. So that was the contextual requirement decomposition that we did, again, along with those safety goals. And now the next aspect is the system use cases and actors. These describe, the use cases are the externally visible behaviors that the system provide, and the actors are the external elements that, or actors that interface with the system. So we identified 11. Top level line is our system of interest, the EES, and then we have a number of other external actors that interface. So for example, we have the park guest, and then we have a specialization of the park guest, which is the attraction rider. Because not everyone at Juniper Cove is going to be riding your ride, but they still care about how it sounds, how it looks, does it take away the food trucks that used to be parked by Old Glory, and so forth. We have other actors like the operators, the safety governance bodies, park maintenance, yourself is also a stakeholder that interacts with this. And then we have external systems like the residents in and around Juniper Cove, how do we consider them with traffic, and the infrastructure, which you provided a number of capabilities on this existing infrastructure. So these actors are then associated to the use cases, and this is a use case diagram which shows that. So at the center is our overall mission thread. This is the main mission that our system of interest needs to provide in order to meet your requirements, which is to provide an entertainment experience. And we decompose this with some specific capabilities, which we'll flesh out in more detail in our full functional decomposition. So a couple of these are the maintenance of the attraction, which associates park maintenance and the infrastructure. Then we have some capabilities like the ability to board and deboard the ride and operation of the ride as well. And then on the safety side, we have the influence of safety governance bodies as well as yourself with the internal standards and our use case for obtaining safety certification. These use cases are then traced to specific functions, which is shown in the owned behavior. So the use cases are the very high level external capabilities that the system needs to provide. The behaviors in the functional decomposition are the more specific operations or the behaviors that specific elements and aspects of the system of interest need to provide in order to deliver on those. And we can see who it influences with these associated actors, and then we show the requirements that are traced to our use cases. So why do we have a requirement to obtain safety certification? We can see the traceability back to a requirement that you provided for industry and internal safety standard compliance. The system context, BDD and realizations, this is beginning to decompose the structural definition of the system, where we take the external actors and we create structural elements first at a context level, and we use these to assign functions beginning at the entertainment experience level. So that's what this looks like when we also refine that system context level with a detailed logical architecture. So again, logical architecture, we're still staying solution agnostic to allow flexibility as our design develops. These are shown across the top of this allocation matrix, whereas the functions are shown in the rows. And these functions are the specific behaviors that the system needs to provide to meet your requirements. And they are assigned to each logical block. So we do the functional decomposition first. What does your system need to do, or what does the system need to do to meet your requirements? And then we decide what the structure needs to be to achieve this. And that's where this is done, where each of the functions is assigned to one of the key logical architecture subsystems. The decomposition of the architecture is shown in that top diagram, where we have the entertainment experience at the top and the key subsystems below it, and the documentation of those is down here, again showing that traceability back to the functions that each of the structural elements provide. The physical architecture is the next stage in our structural decomposition. So the physical architecture provides additional specificity to the logical architecture in that it realizes the logical architecture components and it begins to add specificity. So we may have a generic 4D experience system or virtual experience system at the logical level. We then will refine that or realize that with or you can say like on-person glasses or Google HoloLens, try not to use trademarks, but that's the physical decomposition, so specific solution choice that we've made. And those physical elements we can assign to that physical instance of the system properties that meet or satisfy our requirements. So a couple of examples here. Again, we have that operational uptime requirement and properties or part properties, the backup and primary auxiliary systems that meet it. We can see we've assigned a constraint block that the system needs to meet your requirement of 50 riders every 10 minutes. And then we have value properties, so these are design variables, targets for our system, that we're going to have a 15-minute ride duration and handle 100 simultaneous users, which would be 400 riders per minute, and that's how we can meet the constraint block of that capacity requirement. This is how we can do the decomposition between the value properties to the requirements shown in a different viewpoint. And then on the verification side, we have, again, what are called test methods, and we use these to verify compliance to both your requirements, the stakeholder requirements, as well as our overarching safety goals. And that verification is shown in this column here. And we also have additional detail going back to our timing plan for test level and test type. So are we doing a subsystem test? Are we doing a system test? Is it stress? Is it performance? So here are the initial test methods which we'll utilize to test against your requirements. And we have further traceability back to artifacts, which are the industry standard. This was the ASTM standard for amusement parks that you provided to us. So you can see that end-to-end traceability here. We further elicited some detailed requirements, and we'll jump over into the model to quickly show two aspects. The first of which is going to be how does the architecture solution meet the requirements. So this is a very related table. We have all of your stakeholder requirements again shown on the left, the 20 of them. We have a risk that we've assigned to each of these, and so without any analysis, we assign the risk as high because it's an unknown, and we document that here. But we've noticed that some have been transitioned even into the low category. That's because we've begun to conduct the analysis to reduce them. So a great example is that break-even projection, which we showed earlier in this presentation. So it's traced here as a way to satisfy this requirement, and so we've been able to de-risk the system and it's documented here as well. And between the requirement, we see the derivation again to any sub-requirements that are related to it. The use cases, those overarching behaviors that deliver on the requirements, and then any part properties or design decisions that we've made. And then lastly, for function traceability back to the originating requirements, it's a similar flavor in terms of we're looking at our function list of functions for the overall system, their description here, and then through the use case and structure allocation, we also have this traceability back to the requirement. So you can see end to end, this function to provide audiovisual interaction with the user is related to this overarching system behavior. It's delivered by these structural elements, and here are the requirements that it meets. And same with safety certification. We can see here, it's going back to those top level requirements. So if you have a change in those, we have differences, additional requirements that are listed. We can do an impact analysis to see what architectural elements are affected by that. And again, with the issue with Old Glory, we know that's paramount for you and for your guests to feel safe in their experience. And so your takeaway from this should be, as we develop this architecture viewpoint, we can go from your requirement to the functions, how we've designed the system functionally to perform, down to specific design decisions and the ways in which we test it, so that we can ensure that we meet those safety goals, those guiding North Stars, so that everyone has a great experience. I'll leave you a couple minutes for questions. Thank you.
Thank you.
Do you have any views of your model that shows how your functions interact with each other? Like an activity diagram kind of form?
I did not construct any due to the time constraints. The best I have is the ownership and the sub-function nesting, which is shown here.
Okay.
The use cases themselves, as shown in the diagrams, have the include, so at a level higher than the functions, because the functions are decomposed from the use cases. I can show that if you want.
Sure.
So here, so these use cases interact with this relation of include. So in order to deliver this mission thread, this overall capability, we have to include the ability to operate the ride to align with park and branding themes. So what this would be further proposed per your request with additional time would be an activity diagram with sub-functions and call behaviors.
Okay, great, thank you.
Can you show the project timeline slide?
Yes.
The one where, if I remember correctly, because in B&B, yes, so we placed it, it's a plan, right?
system.
Right, so it's included in the cost.
It's the second portion, so yeah, they could have been divided a little bit
Oh,
more.
I see, you
Yeah.
right, okay, got it.
So we
Oh,
do
sorry.
what we can for subsystem
Okay.
and unit testing computerized,
Right,
and then
okay.
there's a break while we instantiate the system,
I see.
and then we come back and we do final verification when we have the system in place. Because there's some things that,
So
you know, just,
basically, when you're doing the architecture design, they're developing the plan, right?
Yes.
Okay, then they're implementing it over there, okay.
yeah,
Good. Thank you.
thank you.
Okay, I have one question if you want to take it. You're using like language customization, so I think you're extending some stereotypes to stakeholders as well as like test method, right?
A little bit, yes.
Okay,
Yeah, with
just
those
wanted to see.
specifically. Yep.
Yep.
Yeah, otherwise it's a pretty lightweight profile. Try to stay away from too much customization.
Okay.
How'd you like your experience? When do you get to